Okay, hello there. So today I'm going to be continuing to work on Kano script. So not live today. This is just a recording, because my power has been going out and stuff, and I don't want to have to deal with it going out while streaming, because that is a bit of a pain. So I'm going to be recording this one offline and just uploading it to YouTube. Yeah. So YouTube exclusive. Wow. Yeah. So today I'm going to be continuing to work on Kano script. So let's see what we have got right now. Yeah. So we can do this basically. This will work, except. Well, this is actually going to evaluate properly because of the way it works, but it doesn't actually take multiplication precedent into account. So if we do like plus 3 here, it's not going to work. So I can show that. If we go ahead and build it, and then we run it on Kano, and we actually, well, we can look at the generated assembly. This is assembly for my bytecode. Pushes these, and then it adds mul add. So it calls all that. But if we look at, no, if we try to build kano.tasm and we run kano.tim, and we look at the exit code, it's not correct, right? I don't know what the correct one is, but I know it's not correct. It basically evaluates these, and then it will evaluate that, and then this. So obviously we'd like it to take the proper precedence. So that's why I've been looking into this. If I can open it up, precedence, yeah, operator precedence parser. Yeah, so it's like this. And I've been thinking about it, and I think I understand how it works now, basically. And also, I got, from this, so this is, Nunez or Nunes, I'm not sure exactly how to pronounce it. I probably should ask, but, he actually gave me this, and yeah, it's a Rust project, but it was quite helpful. And basically, it's an implementation of a Pratt parser, which, that is on here. It's like the same, it's not exactly the same, but it's a similar algorithm, right? So, predates precedence climbing, it's viewed as a generalization of it. So, right, they're closely related. So it's helpful for getting an idea of how it works, right? Like the parsing primary and such, which is mostly what I was confused about. So I think I understand it now. So I'm going to try to implement that, right? Alright, so let's go to parse, right? We call that. And we have parse expression. So we need, we're going to need a few different things. So I'm going to basically make it based on this pseudocode here. So we have parse expressions, that's this one. And then we need parse expression 1. Yeah, so parse expr 1. So I'll probably rename that because I don't like that name. But for now, token array. So we're going to need to take some other things other than that. But we'll start with that. So let's see what we need. And then we also are going to need a parse primary. So that's going to return an expression as well. Parse primary, right? Token array. So they're all going to take the tokens. Yes. And then they're also going to take some other things. So parse primary. We can look at the implementation in here. So what I can tell is it basically returns an expression. Just like if it's a number, right? It's expecting it to be a number, and then it returns that, right? So if you're on the first one. So like, let's say we have 5 plus 3 times 2. So we look at this and we parse primary. So it's going to return this as like an integer. And then it's going to use that as the value, right? So that is my understanding. I'm pretty sure that's right. So we also need to check that it is that. But so we can get our token from it. So let's see. Basically we basically want to consume the token. So we will. Let's look at. So token consume, I don't think that returns anything. Let's see, token consume. Yeah, it doesn't actually return the token. So we can get the current token and then we'll consume it, right? So we'll do token equals just basically the current token, right? So token's data, like that. And then we can token consume. That will remove it from here, and it's not a pointer. It's not a pointer, so we're good in terms of that. And then we can just if token.type does not equal, it's not equal token type int. I think that's what it is. Then we're going to basically print in there like unexpected, or hang on, expected the no %s but found %s. So then we'll just print out what the token is, right? Yeah. So token types. So we expected TP in, but we found token.type. So that should print out what we got and all that stuff. and that's going to exit on its own. And then otherwise, we're going to just return the token, right? So that's going to return, we don't want to return it just as a token, though. We want to get the value of it and create an expression based on that. So we'll basically create an expression, right? It needs to be a pointer. Expert equals custom reality. Null size of expression. I'm trying to get it so that we're using the macro for all allocations, so that once I switch over to the arena, it's going to be a bit easier, right, to work with. We'll allocate that. And then we need to set expert type equals expert int, and then expert value dot integer equals tokens data 0 dot value dot integer. So we have like the whole value there and everything like that. I think we can also do like expert equals expert, and then type equals expert int. Let's see if we can get the token, because we can't do that. For int, and then dot value equals tokens data 0 dot value dot integer, and we need to set actually value dot integer equal to that. Whoops. Okay, and that's what we're going to return. So return expert. Okay, so that should be parse primary, if I'm not mistaken. And then we can look at the next part. So we need parse primary, and then we need this parse expression 1, which is going to be this one, right? So yeah, so let's actually do an early return here. Just for that, so it cuts it off basically. And then what we're going to do is we're going to do this, right? So we're going to return parse expression 1. We need to actually move it above, but that's okay. So we're going to pass the tokens there. We're going to pass the left-hand side, which is going to be parse primary tokens. That's going to be the current token, right? When we call this, we're going to look at the current token. And then 0 is the precedence. All right, so that's like the starting precedence. So they're all going to have precedence, and we have those saved based on the operator type. Yeah, so we're good with that. So we don't actually need to. So we'll return that there. We're going to need to move this above because we don't have the prototypes right now. So I'll just put it right there. Whoops. There are some issues with copy and paste, which I am thinking about ways to make it better. In Kano specifically is what I mean. Okay, then we're going to implement this algorithm. So look ahead. So we're going to peak next token, right? So it's actually operator OP equals equals peak next token, right? So token peak. So it's similar to what is that? Tokens and then 1. So we're just going to look 1 ahead, right? And then wall OP let's look at OP. It might just have OP not precedence. I'm just gonna do that. So assume that it is. I cannot spell. Precedence is greater than or equal to min precedence. We don't have that, so we need that actually. So we need the expert left hand side, and then the in precedence, min precedence. All right, so that's important for the recursion, which I'll go over sort of how the algorithm works as I understand it. Once we implement it. So while it's greater than or equal to that, we're going to set OP equal to look ahead. So, okay, so we don't want to do that exactly. We want this to be look ahead. So this will be a token actually. Yeah. So this is yeah, look ahead. Okay, so let's call it that. Look ahead. So we don't have the precedence of it. So we need to actually convert it to a binary operator. So how do we do that exactly? Let's see. Token is OP. So we have that. How do we? Let's see. So we get the token here. Let's look at how we do that. OP token. Create operator. Yeah. So I think we want to call that create operator, which returns that based on the token type. Okay. Yeah, so let's actually, let's do that, because we need it to be an operator to do that. So let's do operator, look ahead, so we'll still call it that, equals create operator. Well, let's do, token equals token peak, token 1. So then we can save that, we don't have to call it a bunch of times. So we'll do token.lock, and then we want token as well. So I'll create the operator. So that should do that, but actually we might want to check. So let's just if token, if not is operator token, then we want to just basically print an error, right? So print error expected operator, but found, and we'll just print the token type. So token types token not type, like that. Yeah, so I think that's good. So look ahead, and then we have the actual operator there. So I think, do we actually change look ahead here? So we'll do operator OP equals look ahead, right? So we'll set it equal to that. We want to consume tokens. So token consume tokens. We have the operator actually saved here. So we're good in terms of that. And then right hand side, so let's do expert right hand side equals parse primary. So that's like parsing the single one. So if we have like 5 plus 3 plus 2, we start with this one, like the 5. Then we parse that, and now we're on to this one essentially. So parse primary, so we need to pass tokens, and I guess that's it. And then we need to set look ahead equals basically the same thing here. Let's grab all these, make that, paste it in there. Okay, so same thing there. And then we need nested while loop. While look ahead dot precedence greater than precedence is greater than OP, greater than OP dot precedence, or a right associative operator. Okay, so we don't need to worry about that. That's like different types of operators. That's not something to care about. But if it is greater than that, then we want to call this. And what we're going to do in there is we're going to say right hand side equals parse expression 1. So call this recursively. We want to pass right hand side in there, and we want to pass op.precedence plus 1. Plus 1 if look ahead precedence is greater. Yeah, and it is greater because of how we are checking this here. So we're good in terms of that. And then we want to peek next hope. So look ahead equals create operator. We need to actually we need to get the token again. So we don't hang on, let me see here. And equals that. So yeah, we need to redefine the token. So token equals token tokens 1. And we're gonna do this again down here. Just like that. So then we're good with that. So that will create that. And then we want to set left-hand side equals, which we already have left-hand side, so we pass it. So we're going to reassign it, right? Left-hand side equals the result of applying OP. Alright, so we need to create an expert, I believe. Expert like this. So dot left-hand side equals left-hand side, and dot right-hand side equals right-hand side. We need to define it up here though. So let's do expert right-hand side equals. So let's see, we don't need to allocate it. So we set it to null, and I think it will get allocated, right? That might not work though. Well, no, because we're reassigning it, so we should be fine. So we don't need to define it here. We just need to do that actually. We don't need to do that. Okay. So I think we are good with that. Right hand side. And let's see. And then the dot operand, I think that's what we call it, equals OP. So let's we need to find OP here as well. So operator OP equals 0. And we can give it a this. And then I'm just going to assert, and I think it's fine to assert this because if it's wrong, then that's a problem with the code. We just need to assert that that right-hand side does not equal null. And then we will return left-hand side at the end. So that should be all of it, if I am not mistaken here. Alright, so that should be that. So let's see if it compiles. Let's go through the errors, right? Built in. And there's quite a few errors, which is expected. So it doesn't like this. Missing braces for that. Okay. It doesn't let us do this. Whoops. Let's see. Why does it want so many braces around it? Can I just say, left-hand side, left-hand side equals left-hand side. I don't know if that's gonna break stuff. Right-hand side equals right-hand side. I don't know if I can do that, but let's try that. Let's get into this. Expert has no left-hand side. Oh, yeah. So we need to set it as a binary operator. So that's what the issue is. Equals an expert. So left-hand side, we never actually set it to a type binary operator, so we need to do that, right? So let's do left-hand side type equals bin up. I think I can do that. And then left hand side bin dot left hand side. I think that's what we have to do there. It's no attribute named bin. Okay, so the expert does not have that. So what does the expert look like then? The definition of it, right? Yeah, right here. So select expert. No, it's down here actually. Value. Okay, so we need to do value dot bin. Yeah, okay, value dot bin. So let's do that. Value dot bin. Dot bin. Okay. Yeah. Build that. Okay, and expected token type, but operator is that. So we need to pass the token type in here whenever we call this. Token dot type. And here as well. It's actually 3 instances. Token dot type. There we go. Build that. And yeah, that needs to be parts expert one. That's my bad. Okay, so declared here. Too few arguments. We need to pass the tokens as well. Okay, expected token array, but argument is of type token. We need to pass tokens when we do consume token. That, okay. Precedence and int. Okay, yeah, this needs to be a precedent. Precedence. Okay, bin up undeclared. Its type is expert bin. That's what I meant. Okay, in there it does not like that. Lock row, lock call. I've had a lot of problems with this. I feel like I should just make it a function or something because, yeah, well, it has not worked very well. Expected that before token types. Why? Alright, that is operator is not right either. I think it's is operator token. Token is OP. Yeah, that's what I want. That's it. Token is OP. Okay, and then let's see. So this print one, which one is it? Is it both of them? 448 is where it does not like it. So print error expected that. Oh yeah, because we don't pass the location, right? So we need the token dot lock. That's what the issue is. That. Tokens is set but not used in parts primary, really. We do use it here. Tokens arrow data 0. That's what I wanted to do anyway. Okay, that to match this. We want comment. Okay. Print error again. I think I forgot the location again. Print error. Where else did we print error? Right here. Not lock. Okay. Alright, so we're getting there. Declared here. Token consume 433. Yes, we need to pass tokens there. Alright, so it does compile. I don't know if it's going to work, but we can try it. Kano.kano. Expected operator, but found integer. Also, yeah, we don't need that extra error there. So we got that. And that is 233, really. 33 else. That's way too far. So that got messed up as well, which is kind of interesting. The location is not right. So let's actually, let's step through in GDB, and let's see what we've got. So let's break parse expert route. So on the first one, so we'll run kano.kano. Yes. And we'll take a look at what we've got. So let's look at this. So we want to step into this. Parts primary. Okay, so let's look at token. So it is string is that, we don't have that. Integer is 6. So the value is 6. And if we look at, let's even make a new window. So we can look at the Kano not Kano. So 6, that is the first one, so that's right. So next, and then, alright, so that worked. And we allocate the expert. And we set the value equal to that. Okay, and we return the expression. So that's all good. And then, I should have stepped. Run again, yes. Okay, next. Step into that, next. So now we're back here. So we will next. Alright, so let's look at the token, right? And this token is 3. Why is it 3? Did we consume too many tokens? Actually, we might have. Oh shoot, we don't want to peek 1 ahead. We want to peek 0 ahead. Yeah. Okay. That's what we need. Because we're looking 1 farther than what we want. So we want to look at the current one. So I think that's what the issue was. With that, at least. Now let's try it. Expected operator, but found none. That is interesting as well. So let's look at how that happened. Break, parse, expert, run. Yes. Run with Kano, that's not bad. Okay. Next step. Next. Print token, actually. So that is 6 still. We'll step here. Okay. Next. Print token. So now it actually is 50 plus. That's all good. Look ahead. So we create the operator. So let's print look ahead, right? Do we not assign OP? Actually, that could be an issue. That could be where it's none, you know? So OP plus. Alright, so print OP. So we do actually assign it there, so we're good there. We consume token. Let's print tokens. Tokens.data 0. And let's look at the top one. So it is 3, so that's where we're at. So we parse the primary now from that one. So we'll be looking at 3, so that is good. So we can next there, and we're still good. Print token, so that is multiply. Look ahead is create operator. Okay. Print look ahead. And let's print, so the precedence is 2. Let's print OP dot, let's just print OP. Precedence is 1, so it's greater than that. So we're gonna go into there, and we parse expert 1. Print right-hand side. Print right-hand side value. So value is that, so it's OP plus, okay. And let's print right-hand side value dot left-hand side. Side value dot bin dot left-hand side. Value dot bin dot left-hand side value. And we've got that. Okay, so yeah, that is another expression. So that's what we've got. Token, so we peek the next token. Let's print the token. TT plus, the value, yeah, so it's A plus. Why is the column 39 though? I need to look into that because that is a big problem. But then create the operator. And then let's print look ahead, right? And we will print OP. So they're the same. So it's not going to be greater, so we'll go here. It's not null. So we set that. And then we go here, and let's print look ahead again. Look ahead. Let's print min precedence. Precedence is 1, so we're good. No, okay, so it's equal to it, so we have to go through it again. Print OP. Okay, let's print the tokens.data 0. Integer of 3, so there's 3 again. Okay, so I think we're at the last one, actually, is why that is. Because if we look at OP, it is plus, yeah. So we go through all this, and let's print the token, and it should be none. Okay. We should have actually checked that. So that is where that happens. Yeah, so we need to check that it is an operator. Yeah, because we check it up here, but then we don't check it for the rest of them. So we need to do that each time. So I'll probably make a function or something like that for this. But that's where the issue was for that. So token P. Alright, so we can get rid of all of that. We'll quit out of this now. Build it. And try to run it now. Expected operator, but found none. Still. Just make sure it's saved. Yeah, so it's still found none. That is interesting. So, token peak. Let's look at token peak actually. It's less than peak by. Or if it's equal to it, right? Like if the count is 1, we cannot peak by 1. So we need to do that. And now I think we're going to get an error, right? Token count was 0, but expected +1. Yeah, so it was 0. So if we can't do anything with 0. So that's what the issue is. So we are peaking too much. So we can't do that. So what we do need to do, let's go to, let's just go to parse expression actually. And let's see, so what do we need to do for this? So does this not say, so look ahead. So, perhaps we could even just return type none, in that case, instead of printing an error, Just return token 0, And if it is a token type 1, then we'll have that issue, So the operator but found none. Still, okay. Yeah, we don't want to print an error if it's not. We just want to break out early. Okay, yeah, so we need to just basically break here in that case. And so for the first one, we still want to check that. For the second one, we might just want to break. Well, we don't really want to break out of this one, though. So let's actually do, if token is OP, then we'll do all this, Like that. Okay, so if it is, then we can do that. Build that, and now run it. Token count does not equal 0. So token consume actually broke it. Let's see, so we call token consume here. So that's probably the one that failed, right? We go here. Let's do if token count greater than 0, then do token consume. Can we do that? Or is that going to break stuff? So what other one would be calling that? Let's run VDB and see where it actually breaks. So break on. Let's actually. Can we just run it? I think we can do that. Enable. Let's run with dot. Okay. That wasn't very helpful. So let's run it again. But first we're gonna break our expression and run. Yes. And let's just step through until it breaks. Okay, that wasn't very helpful. Run. Next. Okay, run. We're gonna have to step through. Step. Look ahead. Let's see. There's one. Okay, so we're still going. OP. Print tokens count. 2. Okay, so we consume another one. So let's print tokens data 0, which is an int, so we're still good. 3. Wait, what is the next one? Tokens data 1. Look at that. Data 0. So I actually consumed both of them. So we're peaking, and then it's not an OP. Oh shoot, I see what happened. Okay, so we need to reset. We need to change it basically. So I think what we want to do. Okay, it's OP. Okay, let's look at create operator. What does that do? We just return operator. 0. Instead of that, you know, and then we don't have to check this. It's just going to be, you know, it's not going to be an operator. Maybe. So we still need to assign look ahead, right? That's the issue that we are facing. Yes. Use parameter lock. Okay. Count. So it still did that. Let's go back up. So, because it just kept looping, right? It wasn't setting it. Let's not do this yet. Okay, I'm not sure. Whoops, that's not what I wanted. Let's see, so we still want to make sure the right-hand side is not, oh, that makes sense. Look ahead. Hang on. So what if, can we store the precedence in the token? You know, when it is one of those. Let's look at the token, right? When we actually parse one of those. Let's search for, actually, let's see. Is operator. We create it. And then, okay, can we set the value? Operator, whoops. Okay. Yeah, I want to look at the definition of that. So token is that, and then pt plus, right? Well, we could just, well, we don't, how can we get the precedence from that, you know? Actually, let's look at the precedence. So where's that defined? Precedence. Right here. So we have that. So when we create operator, we actually set the precedence in there. So what can we do here? Well, look ahead to basically just be a token, you know? Let's do this. Look ahead. If it is not that, look ahead, then we're going to do this. Well, no, we don't need that. Well, no, we do need that, because in this case, we're going to need to call that. Well, no, we just want to break in that case, so we don't need this. That is actually an issue, right? So we can get rid of this look ahead. And then we don't have the precedence. Maybe we should make operator get precedence, you know? Let's do that. So we're going to return precedence. It's op get press. Just get prec, right? Are we going to do it from a token type? I guess that would be okay. Token type. And then we're going to do something like this. Right. We'll return prec 0. We don't have prec 0 though. So let's actually add that because we want a 0 prec, right? 0 with prec. That could even be where the issue is. Yeah, so let's do that. Prec 0. Yeah, because then, ooh, that actually is a big problem. Okay, I want to make sure that this equals 0. Yeah, I forgot the prec 0. So that's what we want to return then, in that case. Alright, that actually might fix all of our problems. Adding the prec 0, because that's kind of important, because when we pass that, that's what it is. But let's try to do this. So op get prec. Prec 0. This we're going to return prec 2 for both of these. Do that, and this one's going to be return prec 1. And there we go. So that should be good for that. So op get prec, and then we can do this here. op dot precedence equals op get prec. Right. And then that would just set the precedent. So we don't need any of this. And we could do the same thing with this. We could probably make an array for this even, you know, based on the type. It could correspond to that, but I'll do that later. So for now, this should work then. So, parse primary. We do want that because it has to be an int. And then this, we want to do, well, op get prec. Look ahead. dot type is greater than or equal to minimum precedence. Okay. And let's see. So then we don't want look ahead to always be that. So this would be look ahead again. Look ahead equals peak token peak, and then well, if you get prec from that greater than that, yeah. So that same thing, and then this is going to be look ahead. All right. So let's see how that looks now. So we build that. Print expert is defined but not used. All right. I think I forgot a semicolon somewhere. Probably up here. You know what? Actually, it's probably with the precedence, you know? Did I mess this up? 0? Maybe not. Unused perimeter lock. Oh, yeah, so OP cannot be that. 462. This needs to be a create operator. Look ahead dot lock and look ahead dot type. So we need to do that everywhere that we, well, I guess that's the only place I do that. A token. Oh, but it's expected type, so that needs to be a type. Look ahead dot type. Alright, build that. Range parameter lock, that's okay, I'll get to that. People are be missing a something somewhere, and it's messing up the main function. Print extra around that. It's really hard to tell where it's coming from. We didn't modify anything down here. Did I delete a bracket, a parenthesis? No, what's it called? A swirly brace. That is important. Parse expert. We have this. That's fine. This one is fine. So it's all fine here. This one we didn't actually change, so that should be fine. Ooh, you know what? Maybe not. Turn false. Turn true. Oh, I see. There we go. Yeah. Alright, so when you turn the light, so now we're good. So let's run this, and that still failed. Let's step through it again. So let's break on parse expert. Run. Whoops, and run dot panel. Okay. Next, step into that. Next step. Okay, next. Let's print look ahead, which is TT plus. Okay. TT plus, that has 1, and then min precedence is going to be 0. So we're good there. Oh, but that's good. So before it was setting it to prec 1, which is not what we want. So let's print OP now. Precedence is 1. Okay. We do that, and let's print tokens beta 0, which is a 3. Okay. So that's the second token. We can keep going. Let's print look ahead. That's going to be multiply. And that is greater than OP precedent, so we're going to go here. And then we can print look ahead again, and that's plus. And print OP, which is prec 1. So it's not greater than that, so we're good. And, okay, so we go through this, and then now we're here. So let's look at look ahead again. And min precedent is still 0, so we go here. So I think what happens is it never gets set to 0. Greater than or equal to min precedence. I think we want the precedence to be 0. Actually, we can look here. So does this have precedence thing? This one from Nunez. Print look ahead. Is that's not okay? So at the end. But then we're still here, so look ahead is none. But it's equal to the main precedence. So for the main precedence, I think we want to pass 1. I think that is what we want. What do we call it? It's up here. Parse primary. No, it's this one. Parse expert. Let's just let's pass one and let's see what happens, right? Save that set. Okay. Let me just make sure it's saved. Trying again, just to be sure. Yes. Okay, so let's run GDB again, and this time we'll look at it in this case. Great, parse. Let's just go right to the one. Run Kano dot Kano. Yes. Okay, let's go here, print look ahead. Let's print min precedent, which is 1. Okay. And we can go through all of this. Let's print look ahead. Okay, so this is like in the now. So we return that. Now we're here. Print look ahead. PT plus. And let's print don't have to. Now we're there. Look ahead, which is TT plus again. Min precedent is still that. Whoops, I spelled it wrong. Precedent. Just go crack one, so we're good. Print tokens count. Okay, so we're still good there. So let's print tokens count, and it should be 0 now. Yeah, so then look ahead. Look ahead is none. So that's going to be 0. Look ahead. And let's do even open get. Right. I think we can do this, maybe not. But look ahead dot type. X 0. Okay. Min precedence is 1. Okay, so then we X out of here. Step. Okay, then we're here. But then we try to call that again. We append that. The append, okay. And we try to consume another token. So that's where it breaks, actually. Let's just do that if the count is greater than that, you know? So if tokens count is greater than 0, then call token consume. Okay. Quit. And yes, and build it. I guess it's dot, because it's not a pointer. I think it's not Kano, it's main, Kano dot Kano. Segfault core down. Okay. So that's probably in. Let's see if we can print the tree here. Do we have print tree? I don't know, but let's just get rid of it. Well, I is less than root penalty. I plus minus, and just print that. That's not really going to be helpful, actually. But let's see. I don't think it's segfault in there, right? It is not. Okay. So let's maybe get through the generated code. gpd.flash-min. Click on generate. And run with Kano.Kano. And let's look at this. So let's step through. Type native. So this is the right. So the right is fine. We can just leave that. And then we are on native exit. Okay, so we do that. Go here. And compile expression. And let's step through that. So let's print expert. For value. So I think that this one has left hand side and the right hand side. Precedence is 0. Why is the precedence 0? Print expert value. Precedence is also 0. So we must not be setting the precedence properly. But it doesn't matter in this case, right? It should. Expert value dot bin dot right hand side. Value dot bin right hand side value. Expert value dot bin dot right hand side value. Which is that, Oh shoot, I think we get stuck in a loop. Yeah, so I think there is a problem. We just keep setting it to the left hand side. Because we're just continuously calling it on the left hand side. Okay. That's obviously not good. Quit out of that. Yes. So, in the generation, why does it do that? Okay, so we set it equal to that. We can get rid of this next. We don't need it anymore. Parse expert 1. So we parse all this. And let's compare it to this one. So look ahead, we beat the token, and we just initialize all of these. But do we need to do that? Oh shoot, we need to set the operator. OP equals OP. But yeah, we don't need to initialize this here. And we don't need right-hand side here either. So that will fix a lot of that, right? I don't think it's called right there. It's called operator. Operator. But it needs to be bin, not operator. Value bin. Okay, okay. Okay, I guess it might be OP. Okay. RHS undeclared. Yeah, we need to declare it here. So let's do expert that. Okay, OP undeclared. We need to declare that as well. Operator. Build it and range perimeter lock. Okay, that's fine. So that doesn't work. Let's see what we've got. So the type is expert bin. We need to set the type, so that is important. So when we're calling this, the left-hand side might not always be bin though, I think, is the thing. So if we get into here, then it's bin. Is that right? If we're in here, the right-hand side becomes bin. Right? I think so. Okay, well, let's step through it. So, we peek the token, and then while it is a binary operator whose precedence is greater than that, then type is that, OP is create the operator. So yeah, OP is the look ahead. Then we go to the next token. So we token consume. Then right hand side is parts primary. Yeah, so we call that. And then we look ahead again and peek the next token. So we're going to parse the primary, and then, yeah, now we're on to the token. And then while it's a binary operator whose precedent is greater than OP, then we set it to this. So we do all that, parse expression 1. OP precedent plus 1, right? Yes. And then look ahead is the token peek. Okay. And at the end we set the result of OP with operands left-hand side and right-hand side. I think that's right. I don't necessarily understand that last part. Maybe we could see in here. Left equals that. Box new left. Box new right. And the kind. Yeah. So that's like the same thing that's going on here, basically. Then we return the left-hand side. So yeah, this is pretty much like that. It's a bit of a different loop, but it's similar. Okay, so it does not work. So let's maybe step through and look at everything. And break. First expert 1 to enable. Volcano, yes. Okay, so print look ahead. So we're looking at TT plus. And let's print left-hand side value, which is integer 0. Why is that? That's not right. It should be 6. So maybe let's even break on third parse expression. Yes. Parse expert. Enable. Run enable.can. Yes. Alright, so let's step into that. Parse primary. So print token, which is integer of 6. Okay, token consume. So we consume that. We do that. And print expert value. Integer. Okay, so that does not work. Yeah, I see. We want to use. Oh shoot! We want to use token. Yeah. Because we consumed it. Yeah, token value integer. Alright, do not fix it, but now that's going to be right. So if we break on parse expert, enable, run, kano.kano, yes, and step, print expert value. It's going to be 6. Perfect. That is what I want. So now we're in here. Print look ahead. Print left-hand side value. Okay, yeah, so that's right then. print, print look ahead again. Let's see, so that's plus, and min precedence is gonna be 1. Okay. Right. OP. Data operator, print OP. OP plus, So that's right. And then we can print the tokens data 0. Okay, which is 3. So we had the 6 and then plus and 3. So we're good there. Print look ahead, so it should be multiplied. I mean, now it should look ahead. Tokens data 0 is still that, because we did not consume anything. Right. Yeah, but we consume it when we call it again. Okay, I see. Print look ahead, which is pt multi, and print op.precedent, which is prec 1. So tt mult is prec 2. So we fall into here and print tokens data 0, which is still that. But if we print token data 1, it's going to be inf, which is 5. So that's the next one. Yes. So we go here, print look ahead, and print tokens data 0, which is a plus. So yeah, now we're on to this plus here. Token. So it's gonna fall through this, and we'll print left hand side value. Print right hand side value, which is another one of those. So print right hand side value dot bin dot left hand side. Actually, value dot bin dot left hand side value, which is another one of those. Okay, and print right hand side value dot bin dot right hand side value, which is none. Value dot bin. Right hand side is none. Okay. Why is it none though? That's concerning. I'll make something to print a tree, right? Print look ahead, which is plus. So we still go through here again. So let's print. Alright, so we're on to the last one. So let's look at look ahead, which is the plus. Let's print, let's go next. Print tokens data 0, which is the int of 3. So it's that last one. Okay, and then look ahead is going to become none. So print look ahead. Okay, and then we go here, step through that, and let's print, here. We don't have that. Alright, let's print, print expr value, right? Expr value dot left hand side. Expr value bin dot left hand side. Bin dot left hand side dot value. You just use dot. Yes, okay. Expr value bin left hand side dot value dot, yeah, so for some reason it just becomes like that, right? Expr dot value dot bin dot left hand side dot value dot bin dot left hand side. Yeah, and it's just stuck forever. Why did that happen? That is interesting. Oh shoot, because we set the left hand side equal to itself. Yeah, that's why that happens, right? So it's just sort of stuck in the loop there. So we can't quite do it like that. How do we do that? I'll show you this. So how do we set it here? So we set the left equal this, parse primary, or this or unexpected token. OP is that, if OP.count is that, break. Otherwise, do this stuff. Right equals parse. Let's see. Bin dot left hand side equals left hand side. B dot bin dot right hand side equals right hand side. Dot bin dot OP equals OP. this needs to be casted to an expert. You know, still does that. Yeah, but we're just setting it. Yeah, because we don't. The right hand side gets set to no. Let's print at right hand side value. Right. Can I do that? Because it should be set to an integer always at that point. 353. 353. Okay. So it does go through all those. But then when it's not, oh shoot, because we parse it like this. Yeah, so we don't want to do that though. So I think we have an issue here. Copy get prac. Yeah, we've got an issue, so we don't want to parse it if it is that, right? If we're on to the last one. So what if we do if token is greater than 0? Can we do that? Then we want to do anything else here. Is that a thing that we can do? Get rid of these. Okay. Still seg faults though. Alright, so in the parse primary, we call token consume. We print the token value. So how can we print that? We can print the type, right? Token types. Token dot type. Be a string actually. Integer, integer, integer. Is it seg faulting here? No. Okay. As I should probably step through and debugger it. Like actually stepping through the whole thing. So the parse primary is at some point returning an invalid thing. Let's go and do the gating. Click on parse expert, the first one. Yes. And what is this? This is not parse expert. What the heck? Yes. Huh. Okay, I'm not sure why it was like that. Let's look at token, which currently is 6. Okay. Let's actually break that part. Well, let's quit, right? Yes. And break on parse primary and like step through that, you know? And we'll see what we've got. Alright, so next, token. And okay, now we'll step through. Token. So 3. Okay, so that's the next one. Still on 3. Why is it like messed up so bad? Token. So now we're going to 5. So there should be 1 more 3. Okay. So next. Let me set it to that. So what? Okay, that one's kind of messed up. I don't know why. Huh. Oh shoot, because we were breaking on both of them. That's probably why. No, I don't think so. Parse. Expert 1. So each time that we call this, we want to look at the label. And you're not gonna. Yes. Okay. What is that? What? My DVD is broken now. Okay. TT int. Okay, it should not be an integer. What? The heck? OP is OP plus though. What? Alright, I think it's because we're printing stuff out actually that stuff breaks. So let's go to print F. We had that. What does this word? Print expert. So I would like to call that. I think it's going to loop forever though. Yeah, so I don't think it's going to work there. But let's grab it. Let's move it all the way up here, you know? Because I think it'd be useful up here as well. And let's see. So. Consume. Expert. Yeah, so I want to print it just like in here, you know? Print expert, left-hand side. Alright, what if we actually create a new one, you know? So expert. And then we set, we don't have an expert, so we set the expert equal to this. Equals that. Like this. It's not printing anything either. Expert, let's go back there. It doesn't print anything at all. Doesn't print anything, what? Expert. Int. TT int, right. That's the 6. Now we're here. So look ahead. Is plus. Okay. Expert. Value. Value right hand side. And expert value dot bin dot right hand side. Value dot bin dot right hand side dot value. Which is a 3. Okay. But the left hand side, no, it's just an integer. So print expert dot value dot bin dot right hand side dot left hand side dot value. Which is a binary expression. Okay. Bin dot left hand side dot value dot bin dot right hand side dot value. And that is another 3. Okay. But it is adding. So adding a 3. And then we'll see what the left hand side is. Left hand side dot value. No. dot value dot bin dot left hand side dot value dot bin dot right hand dot left hand side dot value, which is another expression, which is a plus. So we have a 3. What is the main expert? So that is a plus as well. So probably the 6 plus 3. Well, hang on. Alright, why does it not work though? Generate, okay. Type native, right. Then native exit. It's like 1 off for some reason. Alright, step into that. And we are looking at this. So let's keep going to the left hand side. So the left hand side gets stuck, right? That's why it's segments. Okay, so ooh, actually, do we need to initialize it with a null left hand side and right hand side? Probably. Let's see. Do we have? We only create it in the parse expression, you know? Okay, so in here, left hand side bin dot right hand side equals null, as well as the right hand side. Okay, does that help with anything? Yes. Value dot bin. Main kano dot kano. Still seg faults. Okay, so that didn't help. So what would the left hand side be equal to here? Yeah, we always set it to an expert, so that's the issue actually. Dot type equals expert bin. Let's do that. Do that. Instead of setting it up there. So do we actually did they ever return token kind, right? Huh. So because this is the only time, right? So when we call like this, that's the only time we want it to be set to an expression. That's actually break file expression run kano.kano. Okay, let's step into that. So it still is stuck forever. Expert value. It's always that same thing. So it still is recursively pointing at itself. So maybe we don't want to do this. I'm trying to think. So, because we were supposed to set the left-hand side equal to that in here. Otherwise, like if it's just a single one, and we call parse expression 1, then all of this is going to get skipped, you know? And we return left-hand side. And the left-hand side that we pass in would just be a single number. Or if it's plus 1, then we would do that. And we would go through this, and we wouldn't ever get to this point. So let's see what would happen. We'd get the operator, right? And then we do this. Yeah, so we consume token. And the right-hand side, we parse primary, so that'd be like 1, right? And then we pick the next one, and it's nothing. So we skip over this. And the right-hand side is not null. We don't even need that assert, actually. And then we create the expression. look at the expression, which goes to left-hand side. And it points at the existing one, so that'd be 5 and 1. Alright, what if we change this to just be 6 plus 3? Try to go in. Yes. It still doesn't work. Okay, so because it still points at itself, and then it just gets stuck in a loop. Why does that happen though? Turn the left-hand side. Yep. No, we can do this. Shoot, did that actually work? 6 and 3 and add. Okay. Well, let's try. Let's try something more complex. Let's add a times 5 there. So that would be 15 plus 6, so 21. No, so that still didn't fix it. Yeah, when it gets stuck like that. Break. Compile expression. So is it still stuck in there? Okay. Next. Step. We print that. And shoot, I didn't want to step it. Just continue. Next. Why did it say fault? Running it. So we printed the first one. Then we do this. And we got stuck. Why did that happen? Hang on, run. Let's see, so the first one works. Expert value. Mult, okay. Expert value. Plus. Why is the precedent 0 though? Dot in left-hand side dot value. Cannot access that. Huh. Okay, so that's why it's seg faults. So we can like go too far. Can we say dot value dot bin dot left-hand side and stuff like that in here? Same with right-hand side. No. It writes to the file though, I think. So, okay, it's just because it didn't close it, so it didn't work. Because we don't want it to be this. I don't think we want to do this, you know? Value dot in dot left-hand side equals left-hand side. Value dot in dot left-hand side equals right-hand side. Do this first. Left-hand side is the pointer, yes. Maybe. No, not here. Does it work with this still? Or it doesn't have to do that? Still, it's equals like that, okay. Uh-huh. Okay, we need to actually can't really do that though. What we need to do is we need to allocate a new one, right? So extra equals custom reallocate size of extra. And we need to set new equals left-hand side. We point this to new. So it can't point to new, right? Because so we want to copy all the contents of new into well, all the contents of left hand side into new. But then it's gonna point at itself again. Right, because we're updating the pointer. So that's not gonna work. So we really need new to be the left hand side. We don't want the left hand side to point at that, but we need to send it to that. Alright, but actually then we could just return new, right? Wait, hang on. Let me think about this. So if we say new equal to xp, type equals xp bin dot value dot bin dot left hand side equals left hand side, dot right hand side equals right hand side. And that's it. And we get rid of this, and we just return new, like that. And this needs to be a comma. So cycle, it's okay. That doesn't cycle, so that works. But then once we get to the recursion, it does not work. Okay. I don't think it's gonna work there, but if I get rid of this, it should work, right? Yeah, int 0, int 0. What the heck? Oh shoot, that's not good. So we don't want to return new. Whoops. Right hand side. Like balls. Shoot. Okay. I don't get how we could update left hand side though, to not, because it can't point at itself. So we need to allocate a new one that doesn't point at that. And update. Hey, this is, I don't quite get it. It's a bit complicated. So this, right, they call box news. That creates a new one, right? If I understand correctly. They set the left equal to that. But so does the left not point at itself? Where is the left? Yeah, we set the left up here. So let me think about this. Left hand side. I don't know if this is gonna work, but let's try it. Let's set new equal to this, and always return new. But first of all, we need to set equals left hand side here. Like when it's a single one. Still pushes 0 though. So why is it 0? I don't quite get where that comes from. Let's step through it. Let's actually break on parse text. Run, okay, no, that came in. Yes. Set. Okay. The int. Okay. With the integer of 6. And expert. Why is it returning now? Oh, I want it to do. Print new value. Is 9. Why is it 0? So that's not good. That just updates the pointers. That's not what we want. That's not what we want. No, no, no. That's not gonna work. Okay. But that's gonna point in itself, so that doesn't work. We don't want it to point in itself. Say that. But the left is nothing then. That's a problem. So I don't know. Alright, parse inspection 1. Applying OP. So let me think. Let me think about how it would build. So if we have 2 plus 3, 2 plus 5, right? So we parse the primary already. So we have the 2. That is the left-hand side. That's what the left-hand side is set to. And then we go through this, and we'll get to here, and we set the right-hand side. That'll be 5. So we'll have 2 plus 5. Then we set the contents of the left-hand side. We have to do it like that. So the left-hand side equal to the pointer to 2. And the right-hand side is the pointer to 5. But the pointer of this is the pointer of this. So it points at itself over and over again. So we need to allocate a new one, first of all. So expert equals null size of expert. We need that. We need that. New one. And then we want to update the pointer of the left-hand side. But we don't actually want to update it. We just do left-hand side. Left-hand side. Why would that not? Look ahead undeclared. What? Oh, because we have this 2 plus 5. And that, does that work? Why does it proof 0 though? So why does that happen? Oh, it's probably from setting this actually. Yeah, that is why. So that was setting it to null. But if we add times 3, it's not working. Why doesn't that work? So that's going to change the local pointer of left-hand side to point at new left-hand side. But this one is still going to be the old left-hand side because it's not updating the actual pointer. Well, no, but it's the local one that it's updating. So we are changing it. So let's actually do that. No, that's not going to change anything though. Yes. Print look ahead. Plus. And print left hand side value 6. Okay. And then print right hand side value is 3. Okay. And then we go through this. And we have to go through this again. So print left hand is going to be multiply. So that's what we got. We got multiply. And then left hand side value is 3. And then print right hand side value, it's now going to be 3 again. Okay, so we have 3 times 3, so that's right. That's all right. And then we're going to get to the end here. Allocate the new left-hand side, and let's print new left-hand side value. Has left and right. But it's... Oh, shoot. We forgot to set the operator. That's kind of important. OP equals OP. Yeah. Because this isn't right, actually. So print new left-hand side value bin left-hand side. Actually, that's not right. New left-hand side dot value dot bin dot left-hand side dot value. New side dot value dot bin dot right-hand side dot value. 3 and 3. Okay. It's supposed to be multiplying though, but that's whatever. Okay. And then we go to this again, and it's not that. So print left-hand side. That's left-hand side value, and that should be the same as what that was, and it is. So we return that. Now we're back here. So print right-hand side dot value, and that should be, yeah, that's the left and right. So that is right. And we're here, and we print. Let's go next. Actually, print new left-hand side dot value. New left-hand side dot value dot left-hand side value dot bin dot left-hand side dot value, which is 6. Okay. Value dot bin dot right-hand side dot value, which is that expression. Okay. Let's go here. Print new left-hand side dot value bin dot left-hand side dot value. I spelled that wrong. New. No, I didn't. Oh, shoot, there we go. Print left-hand side dot value dot bin dot left-hand side dot value is 6. Okay, so that's all right actually. And we return that at the end here. So is the issue just with that? It's not bin dot value dot bin dot op. Whoops. Where are they? Tech fault. Okay. Because that was all right. Okay, let's break on compile expression actually now. Create an enable. Run kano.kano. Yes. Print expert dot value. So print expert. So the precedence is now right. So value dot left hand side dot value. Oops. Dot value dot bin dot left hand side dot value, which is 6. So 6 is right. And then if we print expert dot value dot bin dot right hand side dot value. Wait, oh shoot, but the type is that the OP type. Wait, can we print the type of this? Dot value dot bin dot left hand side dot type. It's an int. Okay, so that's actually right. So if we actually step into that, we go here, then we push that, and that is correct. Okay. And now, when we go here, we do this one again, and we get stuck in a loop. Why did that happen? Let's run that again. Let me see what happened exactly. So, actually, I'm going to take a quick break, about 3 minutes, and I will be right back. I guess I'm not live, so it doesn't really matter, but yeah, anyway. Okay, so let's figure this out now. So we print expert value. So that has left hand side and the right hand side. And if you look at the expert value left hand side, whoops, print expert value dot bin dot left hand side dot value. Yeah, so we have the integer there. So that is fine, because then it goes here and it actually prints that to the file, right? Okay. Next. And then we go here and we print expert dot value dot bin dot right hand side dot value. But then that left hand side get stuck in a loop forever. So let's look at that. Side dot bin dot left hand side dot value. And that is a 3. So why does it get stuck forever? So let me go to the next one. Let me print expert, actually expert.value, mult value dot left hand side, or dot value dot bin dot left hand side. Print expert dot value dot bin dot left hand side dot value. Integer is 3. Okay. But what is the type? The type is a bin. That's not right. Ooh. So why did it get set to that? Where would we set it to? Expert bin. Other than right there. Oh, shoot. We always set the right hand side equal to that. We don't want to do that. This is the only place I want it to be set to that. Ooh, okay. That could have been a big part of our issues. Okay, wait, did it actually work? Oh, shoot. Okay, that's supposed to be 9 plus 6. 15. Build slash chasm. Kano dot chasm. Build slash Tim. Kano dot Tim. Echo that. 15. Let's go. Let's go. Let's go. Okay. And let's see if it actually works. So let's do plus 5 more. So that should be 20. Let's go, let's go, let's go. Okay, so it looks like it actually works. Oh man, I am so excited about this. Okay, yeah, so the issue, we were setting it to a bin, but this is the only place I want to set it to that. So I think there's some leaks going on here, but again, I'm going to be doing arenas, and that's going to fix a lot of the problems here. We do have to allocate a new one here. Like, I don't see how we would get around doing that, but actually, we just set it equal to that. So what? Well, I don't think that's going to work. What if we just set left hand side equal to that? What's going to happen? I think it's going to loop again. Yeah, it does do that. And if we do... Yeah, because we're changing the pointer of it. So that's why this works. We're having it point at that one. So that's fine. Yeah, but we don't like free anything or whatever. And yeah, so we'll set up arenas, and that will fix a lot of that. So we run this. What? Oh shoot, because this is new left hand side. Okay, yeah, let me create operator. We don't need that anyway, because it's not going to return that. So we... Oh yeah, create operator. Where is just create operator? There we go, right here. We don't need the location anymore. So anywhere that we call that, we can get rid of the location. Create operator. Create operator. Okay, so I think I was going to go to Okay, so it compiles now. And we can do that. So that's pretty cool. Let's try something else. So I'm pretty sure this should be able to grow indefinitely, essentially. Let's do 12 times 5. We have to do something smaller because we can only, it has to be less than, I think it's 125 or something like that. So let's do 2 times 2 plus 5 times 3 divided by 2. So it should do this one first. So 2 times 2. So that should be 4. Then it should do 5 times 3, right? So that'd be 15. Then it should do, I think it should do 15 divided by 2. Then that'd be 7, right? Because integer. So that'd be 7 plus 4. Right, if I'm not mistaken. I could be wrong. I should actually probably open up Python to make sure. Wait, so what was it? 7 plus 4. So that'd be 11, right? Times 2 plus 5 times 3 divided by 2. 11.5, yeah. So it's gonna be, it should be 11. Kano dot Kano. It's not Kano. Kano. Build flash. As in Kano dot Kano. Build slash Tim. Kano dot Tim. Echo that. 11. Let's go. Let's go. Okay. That's very cool. So it works then. Okay, and now we don't have to, like, if we ever need to parse anything, all we have to do is call parse expression, and it's going to parse it, right? So, and compile expression as well, and it'll compile it. Okay, that is a relief. Yeah, so I'm going to sort of walk through how it works, and then that's going to be the end of the video. Yeah, so parse primary. So that was pretty much exactly what I thought it was. That's good. So, probably can even get rid of this, but I don't know. I'll go through it. Parse native node. Yeah, so we can get rid of this old one here. What we have to do is call parse expression, and then we can set. Actually, this could probably just be set to parse expression. Good. I think that'll work, and that'll make it a bit cleaner. Yeah. And there we go. Okay, yeah. So that is a bit better. So all we have to do is call this parse expression, and that will create all of the expressions for us, and then we can parse them. So yeah, the next one will probably work on variables. So setting them. So something like. So here's the thing, right? I want it to be statically typed because I hate working in dynamically typed language. So when you initialize the variables, it's going to look like this, but hear me out. So using like int x equals 12, just like C. But, this is very important. In the future, I'm going to add syntactic sugar. So similar to Go. So something like this, right? And then it will be able to infer the type. So you don't have to actually specify it every time. Except in like unclear scenarios or whatever. I just think that's the best way to go about it. Because, yeah, I think so. So that's what I'm going to do. So it's going to start with whatever the type is. For now, int, and that would just be a 64-bit integer. I'll get all the types figured out once it's more developed. But yeah, so we're going to work on this. So then we can just call parse expression. It's going to parse the expression. And then we have to keep track of the variable. We'll like push on the stack. And then we won't have scope yet, because we're going to do that once we work on if statements, which should be like right after that. That's the next thing. But yeah, so this works. So let me commit it, and then I will implement order of operations on expressions. All right, push that, and let's go. Okay, so my power didn't go out at all, so I could have streamed this, but I did not. So so let's look at what we've got. So the first thing we call is parse expression, and this calls parse expression 1, which I will probably rename that, but whatever. And that call passes tokens, parse primary of the tokens, and 1. So first it goes to parse primary. And what that will do is just extract, okay, let's do parse primary. Takes a primary. Only supports integer. So like this will, that'll be like identifiers and things like that as well in the future. But in the future, it'd be identifiers, etc. Okay. Yeah, so I just wanted to make that comment so that I remember what it is, So it's pretty simple. So basically we take the token, and then we consume it. So token consume should probably return the token. I think that would actually be useful. Should I change that now? Token equals that. And then if we just go to token consume, it should not be that hard. Token consume. And yeah, we'll just return token. And so we don't want to do that. So let's return tokens data plus plus. I think that'll work. Oops. CD can't build. You can just dereference it, I think. Okay, let's try to run it. Main internet channel. Then try to compile it. I think it's 11 is what we have right now. So Tim hiring Kano.Tim and go back 11. Okay, so it still does work. So that is pretty nice. Yeah, because we had to iterate the token. So that's all good. So that is what we want to return there. Token consume. Yeah, so that's a bit nicer looking. You know what I'm saying? Okay, so I'm going to walk through it again. So we parse that, and we get the first token, and we check to make sure it's an int. Obviously, it has to be an int. We already know it is, so this could even be an assertion, because it should be, unless I mess something up. Okay, expr. Well, yeah. So expr, custom realloc. So yeah, we basically allocate the node for expr, and we set the type equal to expr integer, and we set the value equal to that, and we return that. Because right now it's only an integer. Obviously, there could be type identifier, and we'll set it to that, and all that stuff in the future. That should be a pretty easy change, though, to add actually identifiers and things like that to this. And then we return that. So now we're in here, and the left-hand side is what we just got there. So it's going to be the integer. So say it's like 5 plus 3, it'll be 5. Then we get the token, so that's going to be the plus, we look at it. So we pass the minimum precedence, so it starts at 0. So that's like it starts as 1 actually, the minimum. So it has to be a plus or minus or greater, Operator OP. So also, like we could implement more things, Well, hang on. We could implement more things. So we could have like raise to the power. we could do it like how Python does, something like that. We can implement mod. That'd be pretty easy, actually. I'm pretty sure we already have support for that. Things like that, you know? And it's really easy. Like, this is pretty accessible. Okay, and then we make sure this token's count is greater than 0. And then we consume the token. Yes, we consume the operator token. And then we have parse the right-hand side. Right side be, if it's 2 plus 5, it'll be 5, right? Look at the next token, and then if it's an operator, then we go into here, because that means it's another expression that I have to parse. Otherwise, we continue on, and we create the left-hand side, and we like the new one. We set all the values of it, and then we point left-hand side to new left-hand side, and we return it. Or, in the case that it's just a single one, so like 5, and nothing else, then it's just going to skip over all of this and just return the left-hand side immediately. And that's the expression, you know? So if we have just 2, and then we build it, name, then we can actually just look at the hasn't file, and where is it? Push 1, no, what? Push 2, yeah, it just pushes 2, and that's it. So we can even build it and make sure, but I can read it, so I know that it's tired, not 10, echo that, and it's just 2. So that's pretty nice. Yeah, so hopefully this makes sense. So maybe I can add some comments as well. We don't really need that one. Consume the token, parse right-hand side. Let's see, I want to see, like, where the confusing parts. Allocate new left-hand side node to ensure old left-hand side does not point at itself. Getting stuff maybe. Okay, because that was where it was tripping me out, kind of. And it was also with setting this, right? Anyway, so this works. So that's that, and we point it at itself, and then we return it. So yeah, sure it's an operator. All right, so I make sure it's an operator, and then here as well. I don't need to add that because I can convert that. Okay, and this. Yeah, I don't think we need a comment there. I think the rest of it kind of makes sense. So let's just commit that, and then it's going to be the end of the video. So, I'll add a couple of comments, and improve. Yeah, okay, so we'll push that, and that's going to be it. So, thank you for watching, and I'll see you guys next time.